On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at a related rates problem that deals with the volume of a cube. A cube is expanding at a rate of 4 cubic yards per minute. This is a rate of change of volume since we have cubic yards per minute. At what rate is the length of a side of the cube changing when the volume of the cube is 15,625 cubic feet? Round your rate to the nearest hundredth of a foot per minute. So we have the rate of change of volume. That's going to be the rate of change of volume with respect to time. That's the 4 cubic yards per minute. But let's be careful with this measurement here because we have 15,625 cubic feet. And down here we want to answer this to the nearest hundredth of a foot. Therefore, we need to convert 4 cubic yards per minute to cubic feet per minute before we apply our differentiation and start applying the volume formula and whatnot. Therefore, 1 cubic yard is the same thing as 3 feet by 3 feet by 3 feet. That's what 1 cubic yard is because 3 feet make a yard. If we take 3 times 3 times 3, 1 cubic yard is the exact same thing as 27 cubic feet. Therefore, since our rate of change of volume is 4 cubic yards per minute, if we take 4 cubic yards and multiply it by how many cubic feet that make up 1 cubic yard, 4 times 27, 4 cubic yards per minute is the same thing as 108 cubic feet per minute. That's our dV/dt. So now our second sentence, at what rate is the length of a side changing? So if we have some sides, I'll call them S. We're trying to find the rate at which these sides are changing when the volume is a particular piece, in this case 15,625 cubic feet. Our ultimate goal is to find ds/dt. To do this, let's use the volume formula for a cube. We can take the side measurement that we have for a volume, length times width times height, that's S times S times S. Therefore, the volume of a cube is S cubed. Differentiating this, we have the derivative of V with respect to time is 1 dV/dt. This is the rate of change of volume with respect to time is equal to, differentiating S cubed with respect to time, we have 3S squared. Don't forget your ds/dt. This is the rate of change of the length of a side with respect to time. Remember, that is what we're looking for here. And we're going to come back and we're going to round this to the nearest hundredth of a foot per minute when we get our final answer. However, to get ds/dt, we have to know what dV/dt is. Remember, we did convert that to cubic feet per minute, but we also need to know what S is, the length of a side. So going back to our volume problem, at a particular instance when we're trying to find ds/dt, the rate of change of the length of a side of the cube, we had this instance when the volume of the cube is 15,625 cubic feet. So going back to our formula, volume equals S cubed. We have a particular instance when the volume is 15,625 cubic feet. That's going to be equal to our side cubed. Therefore, if we take the cube root of both sides, we have a side length of 25 feet. That's going to be our side measurement at the instance when our volume is 15,625 cubic feet. Therefore, plugging in what we have, and now we can finally solve for ds/dt. We have dV/dt, which is the 108 cubic feet per minute that we found earlier in the problem, equals 3 times our side squared. Remember the side we found over here. Don't forget to square it, and then we're multiplying by ds/dt. Therefore, if we take 25 feet and we square it, 25 squared is 625. 625 times 3 is 1,875. Don't forget your square feet since we did square our feet here. And to get ds/dt by itself, we can divide by 1,875 square feet on both sides. That will cause these to cancel out, giving us ds/dt by itself. Over here on this side, the square feet will cancel out with the cubic feet, leaving us with a plain old foot, just a standard foot per minute. That's the rate of change of the length of the side that we want according to our question. Remember, it did say round your rate to the nearest hundredth of a foot per minute. Notice we have feet per minute. And going to the calculator to get this measurement, 108 divided by 1875, again we have feet per minute. We get 0.0576, and since we need to round to the nearest hundredth of a foot, 0.06 cubic feet per minute is the rate of change of the length of a side when the volume of that cube is 15,625 cubic feet, given that the rate of change of the volume is 108 cubic feet per minute. And there you have it, a related rates problem dealing with the volume of a cube. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.